one and all present here. I'm Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I'm going to share a small article regarding terminologies used in big data environment. There are 6 terminologies which are used in big data environment. The first thing is in-memory analytics. The second one is the in-database processing, massively parallel processing, parallel system, distributed system, and shared nothing architecture. In in-memory analytics, the data access from non-volatile storage such as hard disk is a slow process. One way to combat this challenge is to pre-process and store the data in form of cubes, aggregate tables, query sets, etc. so that the CPU has to fetch a small set of records, but this requires thinking in advance. This problem has been addressed using in-memory analytics. Here are all the relevant data which is stored in RAM. The advantages is faster access, rapid deployment, better insights, and IT involvement. So this is an diagram behind the in-memory computing. Here there is a traditional computing and in-memory computing. In traditional computing we have application data and application code, and in-memory computing and database of record. But in in-memory computing we have the application data and application code, and separately it is accessing the database of record. So the database consists of persistency, recovery, and post pre-processing and backup. In database processing is also called as an in-database analytics. It works by fusing data warehouses with analytical systems. Typically, the data from various enterprise OLTP systems after cleaning up through the process of ETL is stored in the enterprise data warehouse or data marts. With in-database processing, the database program itself can run the computations, eliminating the need for expert and thereby saving on time. But in symmetric multiprocessor system, there is a single common main memory that is shared by 2 or more identical processors. The processors have full access to all I/O devices and are controlled by a single operating system instance. SMP are tightly coupled multiprocessor system. Each processor has its own high-speed memory called cache memory and are connected using a system bus. Next is the massively parallel processing. So refers to the coordinated processing of programs by a number of processors working in parallel. The processors each have their own operating systems and dedicated memory. They work on different parts of the same program. The MPP processors communicate using some sort of messaging interface, and this is a diagram showing the massively parallel processors. So here we have processor, cache memory, and a bus which is connected to the processor and cache, and also we have connected the memory, and in the bus we have connected the I/O devices. So all are an independent OS runs at each node. So if it is connected using an interconnection network, and there is some sort of messaging interface between them. Next is the parallel and distributed system. A parallel database system is a tightly coupled system. The processor cooperates for query processing. The user is unaware of the parallelism. And distributed database systems are known to be loosely coupled and are composed by individual machines. Each of the machines can run their individual application and serve their own respective users. So it's usually distributed across several machines. So this is a distributed computing, and this is a parallel computing. So in distributed computing we have processor and memory which is distributed geographically, but it is connected with each other with an internetwork so that it can able to process the data. But in parallel computing, one memory is shared for all the processors, and all the processors are connected to the same memory. So next is your shared nothing architecture. In shared nothing architecture, neither memory nor disk is shared among multiple processors. So what are the advantages behind the shared nothing architecture? So fault isolation. It provides benefit of isolating fault. A fault in a single node is contained and confined. Next is scalability. The disk is shared resource. Different nodes will have to take turns to access the critical data. A distributed shared disk system, thus compromising on scalability. So the 3 most common type of architecture for multiprocessor high transaction rate system. So the first thing is the shared memory, a common central memory shared by multiprocessors. The next is the shared disk. Multiprocessors share a common collection of disks while having their own private memory. And shared nothing if neither memory nor disk is shared among multiple processors. So this is an architecture behind the shared nothing architecture. Here we have shared RAM, shared disk, but this is the shared nothing architecture. So each have its own CPU, RAM and disk, but it will be connected to a same LAN for exchanging the information. Thank you.